Ladies and gentlemen, welcome back to the second part of the spare wheel carrier shenanigans. If you haven't seen the first part, I highly recommend you go watch it. Without further waffling, let's get on with it. And the job at hand today is to move that one to somewhere where it wouldn't be in the way in the middle of the aisle in the house. I'm thinking that it should go down there somewhere. The winch we bought is a worm drive winch, and that means that it doesn't need any ratchet mechanisms or anything like that. Basically, you turn it one way, it goes one way, and it turns the other way, it turns the other way. And there is no brake inside of it. The worm gear means that the wire can't actually turn the handle. So only the handle turns the drum with the wire on it. And that's really good because that means I can mount the winch somewhere where it's not accessible by hand. So I don't need to click a ratcheting mechanism up or down or anything like that. The way the tail end of this truck is constructed means that I need to have quite a lot of pulleys to get the winch to a location where I want it. And I also need to keep in mind that this area where I'm standing right now is probably going to be a hatch. So I cannot access anything here. I have to access things from inside here near the rear wheel. So a logical point would be to mount the winch somewhere under the cross member frame rail here somewhere. To get the wire to go there, I now need to figure out a route for the wire to go and where the pulleys go. So today I will probably just be scratching my head and fabric-cobbling something really silly again. That's why you're here, right? Now, I had to open the worm gear winch drive up to check a few things. We deliberately ordered it with a separate handle, and the handle has got one of these two pins on it that you stick into there and then you crank it. But it's also got a 30mm diameter nut on it, so you can use a 30mm socket on it, which is all good. Except for that, I haven't really stumbled across many 30mm sockets on the truck, and there's a 30mm hole, which means that a 30mm socket will not fit in a 30mm hole, but a 17 would fit. So ideally I would just pull this out and remove this 30mm nut on it and put a 19mm nut on it, so that we could use this through the hole and lift the tire with that. Maybe even better would be if I could have a 24mm nut on there, because that would be the same as the wheel, so less tools is better. But it looks like it's not going to happen, so I'm going to have to figure something else out. It would have been really neat and tidy if I could have just used that single hole and accessed the winch from there. It would have been protected and out of the way and all of those handy things. So yeah, well, it was worth having a look at least. It could have been very easy. So the uppity downity stick is in there, and the actual winch is now there. And yeah, there I can get the stick through the hole, and yeah, it seems to work. And then I made a CAD template for the holes. So the big hole there is where, I don't know if you can see it, the big hole is for the stick, and then the three other holes is where I'm going to mount a bracket on the back side there, and then I need to make another bracket for the winch, but let's make this one first and see how that fits. I'm in the process of fitting the bracket here. It's obviously behind the frame rail here, but one of the things that I'm trying to do here is that before I actually drill those holes there to appropriate size and do what I need to do with them, I've put this one into there so that I can check whether I've actually got them in the right location, the other holes. The bracket looks like this at the moment. I know it's not very fancy pants at the moment, but I always build stuff functionally first, and then you can make them pretty or work on them whatever you want. But there's 3 holes to hold it, should be fairly strong. The 2 bolts there are the ones that hold the winch. Now when I know that the holes fit, I'm gonna proceed to the next stage. I just threaded the holes here for M12 bolts. That one is an M8, which means that I was able to test it. I tested it and it fits really well. Everything is tickety-boo. I tested it with just regular bolts like that, and it looks pretty cool from the outside, but the design here is not really good for captive nuts in there, and I don't want to rely on this 3mm, 4mm thick angle iron for strength of holding this in place. So I'd have to weld in a nut there, or I was actually going to weld in a piece of threaded bar in there. Whilst bolt heads are probably prettier from the outside, I think it's actually easier for me to manufacture it if I have captive bolts rather than captive nuts. Captive bolts allows me to put this in place on the frame and simply thread on the nuts on the bolts, the studs that are sticking out there. If I have bolts, I have to find the thread inside the hole. So I think it's easier to make and easier to operate the one single time I'm putting it on, maybe. And aesthetically it probably doesn't look as nice, but because this is hidden behind the rear wheel on the frame, I don't think that is much of a problem. If it was on the bonnet, aka the hood, then maybe I would opt for a nice bolt head instead. But enough waffling about that. I'm going to make captive studs. Some wives have those, so that should be nothing new. And then I'm going to shape it to make it look pretty. But function wise, this is really, really good, and I'm surprised I managed to get it to work. So I'm feeling a bit chuffed here. At the last work session we left the bracket looking like this, and I had to beautify this part here because it wouldn't actually fit. The cross member is slightly in the way, so with the bolt sticking out a little bit too far too, it wouldn't fit in there. But a little bit of a taster of what is gonna come. Without too much waffling, I'm going to cut that piece so that it fits onto the end there, and then weld that in, and then I'm going to cut off all the excess pieces of metal that are not needed. Make it a little bit pretty as per standard. The bracket now looks like this. The corners have been rounded off and chamfered and all of that stuff, and there's no gap here anymore. So yeah, it looks pretty good, but well, if you've seen previous videos, you know I can't leave it alone. So I'll be back in a bit. A few minutes later, and we have this. Speed holes, baby! Yay! Speed holes! If you don't get this, if you don't get stuff on our truck, it's okay. This is our truck, and this is my way of doing stuff. And today I felt like speed holes. And now I have speed holes, and wherever I go in the truck, I can remember this day, and that our winch bracket has speed holes. And that makes me a little bit happy. And happiness is important, people. So make sure you put happiness into the equation too. Speed holes, yeah! Speed holes, yeah! crazy. Welcome to the underside of the truck. Now when I've stopped hitting my head and moving about, as you can see, right here is the winch and the bracket is there, and this here is a string that now is up at the pulley on top of the arm, the tire bracket, and if I turn it 90 degrees it goes pretty much straight onto here, and I am extremely pleased about that. That means that we need to make a holder for the pulley that goes in there, or the spinny thing or whatever, the wheel. I started by making a plate, or actually just cut it. I didn't make it at all. It's 120 millimeters by 50 millimeters, so that should be able to hold the bottom bolts that come from there somehow, and then some arms out there, and then the wheel there or something like that. So let's see what we can come up with. A quick tip for you: if you are creating captive nuts, such as this one that Mercedes did, it's very easy. You basically just put a bolt through and a nut on the other side, and then you just weld the nut and you remove the bolt, and tickety-boo, you have a captive nut. However, if you are doing captive bolts, it could be a little bit more difficult because you want to weld the actual bolt into a plate. What I have found is that if you thread the thing that you are welding the bolt to, then you already have a captive bolt sort of thing there. So now you can thread in the bolt, and you can thread it to the correct depth. You put a nut on the back, and if you then tighten that nut, you can now make sure that it is pretty straight. Here's a bit of a bonus secret: the worse the threads are in the thing that you are welding the bolts onto, the better the nut on the back will help to align the bolt. So if there's a little bit of wiggle room, it's probably just good. In this case you can see that the bolts aren't super straight because they're difficult to thread into a thin plate like this, especially freehand. So by snugging up the nut on the back, the bolts become a little bit straighter. I hope that helps you if you are doing captive bolts. This is what it looks like at the moment. I have just tack welded this stick on here, and yeah, it comes down a little bit too far, but the angle is right. I don't know if I'm going to be happy with that or if I'm going to have to change that. It still reaches the drum over there just fine, so there's no problem. We were talking about good versus ideal here, so it is good, it is not ideal. Do I need it to be ideal? I don't know yet. At the moment though, I'm going to focus on this bit here. I can easily weld on another stick here which triangulates this in the sideways movement, but I also need it to resist the forces coming down from the string or the wire in the future, and to do that I need an anchor point higher up here, somewhere up there, and I've marked the actual tire holder, and I think the solution is to triangulate the top plate to as high up as possible there, with a bolt going through to the actual tire holder, and then make a tab or something, make a thing there. I'm not so sure if I'm making myself clear here, but it's about as clear as it is in my head that I can articulate it. I'm not sure if I made it clear, but because the spare wheel carrier is blocking the hole for the third arm of the pulley bracket, I decided to embed a captive nut into the spare wheel carrier.
It's a pretty easy thing to do. The hardest part is actually to make sure you get the hole and the nut in the correct spot, as I don't think the crossmember or the spare wheel bracket is going to yield to my stupid errors. Once I have the location marked out, I need to drill a hole in the spare wheel carrier, then I need to cut an extension nut in half and round it off to fit in the hole. Then I just need to bang it into the hole. However, I forgot I had chamfered both the hole and the nut to make space for the new weld material. Go!
As you saw, I bashed the nut in a little bit too far, something that has known to happen before, but I managed to get it out by a little bit of prying and bending. It is all good. I then put this threaded rod in and I've screwed it all the way to the bottom, so it's actually now pretty solid there. It is now sticking out a little bit, but that doesn't matter because I'll just blast it with tons of heat and then I'll grind it flush, so nobody will ever know of this little mishap. Don't you tell anyone. We have the tire mounting bracket there, and I have made the captive nut in there. That captive nut goes on here, and these are the two other bolts that hold the pulley bracket. The next thing I want to do before I mount the tire bracket is that I want to make a tab for the pulley bracket, and the tab should go up there to that hole where that nut is. And then I had to think about whether this needs to be repositioned because it's a little bit low, and I think there's a time and place for shortcuts, and this probably is not. For the sake of a little bit extra work of getting that in an ideal position rather than a good position, I'm going to give it a go. As I said, I will be trying to reposition this a little bit further up this way, and the way I think I'm going to do that is that I'm going to scribe 10mm line on the arms there, and then I'm going to try to cut it as accurately as possible. I'm only doing 10mm because I'm pretty certain that I'll screw it up, so I need a little bit extra material there. Yeah, anyway, scribe it is scribe it. I've been spending quite a lot of time now trying to figure out how to attach the third leg of the tripod, and I took a piece of steel like this and I made a kink in it, and now this one fits into here. So the idea is that I need to be able to access this bolt here with a tool, so something like that needs to be able to go in there. But then also the wire needs to be able to go straight up to the actual tire holder, so I can't just stick a stick to the straightest point here. It has to kind of snake around some of the other things, but I think this might work. So I'm going to tack this in place now, and then I'm going to take it to the truck and see if it actually does work. The thing about 3D fabric coupling is that there are 3 dimensions, and my brain is pretty much 2-dimensional, and sometimes it's a little bit difficult to see things before it's done. I don't know if a better way to say that, but that bracket I just welded on to the pulley bracket, the bar. I didn't realize that. I've completely forgot about this bar, you know, this minor thing. So luckily it does seem to work quite well, and there is enough space up there, and the bolt goes in and I can get the tool into there, and the wire clears, and it goes correctly to the pulley. So even if it doesn't look as elegant as I wanted it to look, I think it's gonna have to do. Look, in there from this direction. The wire clears down there, and it's straight in line with this, so there shouldn't be too much flex when we put the weight on. And if we try to peek through here, that's what it looks there. Yeah, from this angle. We'll chalk down this one as a success, and let's fully weld that, find some zen. I think we're pretty much there with the fabrication now, and before I go ahead and paint it matte black so it blends in with everything, I thought it would be a good idea to show you the components and how they all work together. We have three components: the spare wheel bracket, the winch and its bracket, and a pulley bracket to make the wire turn 90 degrees. Then there's also the original wheel bracket from the Unimog original spare wheel carrier that is on there. So I'm going to explain the parts now, and then we're going to lower and raise the wheel as we would be doing out in the wild. You've seen me make the spare wheel carrier bracket, and here it is in place. It is based on 40 by 40 by 3mm box section. We came to the conclusion that we do not want this to come loose in any case, whatever happens. The bracket that is mounted to the spare tire is visible there, and the pulley is just sticking up here with the ability to lift it all through the hole, and the wire goes straight down in between the rails. We have 4 times M16 bolts holding this bracket in place, and then on the sides the triangulation brackets are held in place with the bolts that hold the rear cross member in place too. And I'm pretty pleased with it. It's very compact for what it does, and it's extremely sturdy, and I'm pleased with the triangulation too, because yes, it is very, very sturdy. I should stop saying very sturdy, and we'll go on to the next part. This is the winch we bought, and it is a dedicated spare tire winch. The only modifications I've done to the actual winch is that I cut off the flanges here. There was 4 mounting holes, 2 on each side here, and then I welded this bracket in, because if it's mounted this way, then the surface it's mounted to is giving strength to these 2 sides. And this is the bracket then that has positioned the input shaft right in the factory hole that is here in the frame, and then we're using 2 bolts here and 1 bolt here, and as you saw, speed holes. One thing that I'm extra specially proud about is that in this orientation the mechanism is on the top, protected by this metal cover, and then in here it's just the pulley, and there is no mechanical parts below this, which is hopefully a good thing when dirt and rain and other crap comes onto this thing. Hopefully it'll last a long time and this won't be waterlogged. The third component, being the pulley bracket, is basically 3 legs and the pulley. The pulley takes the wire from the winch and turns it so that it goes backwards and upwards 45 degrees. The bracket is attached with 3 bolts. The lowering and raising process is fairly simple, and there's no mechanical components in the whole system apart from the pulleys and the winch. No hydraulics, no electrics, no hinges, no joints. What you need is the extension stick for the pulley hole that goes into there, like that. And then you can use a regular ratchet handle, sorry, to lower and raise it. Those nuts are 24mm head, same as on the wheels. So only 1 tool, and you can start just cranking it down like that. However, because I'm lazy and time is a factor, we are going to use the magic of electricity. So this way you can now lower it down. However, before the tire will actually lower down, we need to remove the bolts. But before we remove the bolts, we should check that the line is taut and the tire is not going to fall on my head when I undo the bolts. So we quickly tighten it up a little bit, and yeah, that sounds about right. Now the wire is tight like a tiger, and we can undo the bolts. You probably can't see it due to the contrast, but there's now 5 bolts in the 6 lug pattern. These 2 here, the top and the bottom ones, are for the bracket, and then the 3 other ones are attached to the actual bracket. Let's quickly undo the ones that we need to do. 1, 2, 3, and the tire is now hanging by the wire. So this is the dangerous part where you don't want to be squished. Ta-da! And to get the spare wheel, now you need to undo these 2 bolts, and you can undo them even with the tire this way by just sticking the ratchet handle in there and undoing them. And your spare wheel is now free to be mounted on the truck where needed. Lifting the spare wheel is also quite easy. However, when the wheel touches the underside of the crossmember, you can align the thingy that goes into the other thingy. Sorry for the technical terms, it's late in the evening, but let's lift the tire. And now the tire is resting a little bit on the subframe of the crossmember. Now I can easily go here and just rotate it so that this bracket is aligned with the hole in there, and now should be really easy to just do the rest of it. And there you have it. Now I need to put the bolts in. Putting the bolts in is relatively straightforward. You do need to wiggle the wheel tire a little bit if the holes don't align perfectly, so putting one in and then the next one and the next one, wiggling the tire and rotating it a little bit in between might be necessary.
As I've pointed out a few times already, this is not a perfectly safe system, as the wheel is dangling from a wire and work is being done underneath. There's a chance that the wire could snap or something else could fail. In an ideal situation, I would make a device that would prevent the tire falling whilst the bolts are being inserted or removed. For example, propping the tire up with a simple but strong stick wedged in under the rim would be adequate. Once the bolts are removed or fastened, I can simply pull the stick out. Another more elegant solution would be some sort of latch or pin that could be operated from a safe distance, perhaps by using the lifting stick. What I'm trying to convey is that if you build a similar system, please be aware of this and please build in a safety mechanism. You're responsible for your safety.
Bit of a status report. Sorry about the noise in the weather. I tried to ask for quieter weather, but apparently I'm not that cool, so I'll speak up a bit. The rear tire rack has been painted. It has had rust conversion, primer and top coat, 2 of them. And apparently we thought we had bought satin black paint, but looks like it's a bit shiny. Over there is a crazy woman who is trying to get rid of some of the rust that has formed in the past month or so. I have tried to wrap the tire, but I forgot to do the center, so I'll just paint that instead. There's the other two brackets that have just had a second coat of black shiny paint on it. I still need to do the tire, the wheel bracket, and I want to modify the stick, as you know. So that's the quick wrap up from now. I'm going to... For the record, we're not doing this to make it pretty, we're doing it to get rid of the green color, because it's not a military vehicle anymore. Little bit of a progress update. Second day for the spare tire wheel carrier bracket to baste there in the sun. Cass is painting on the truck frame. The other parts are also here in the sun. This is a really thick paint. I hope it still actually fits. Yes, we've painted over the threads. I'm going to probably have to run the tap or dye through the ones that need it. I have modified the stick, so instead of having a bolt going straight through, I now just hollowed out a couple of nuts to fit over there, so now it's a little bit lighter. I don't know why that made any difference, but I had to do it. It's been rust converted, ready for some paint. The bracket for the spare tire has had a few bits welded to it, maybe just to make it look a little bit nicer, and then 2 coats of zinc primer and 2 coats of satin black. So I'm now going to take that out in the sun and get the stick in here and give that the same treatment. Glamorous work this. I have now spent a few hours cleaning up the threads that had paint on them. I've added copper slip, I've got the new bolts, I matched the bolts, I've cut some bolts, and I have basically checked that every hole still works, every thingy still should be okay. That's a technical term again, because my brain's a bit overwhelmed as usual, but it looks like everything now has been, you know, kind of fallen into place. So click. 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 The winch is now ready to take the spare wheel tire, and as you know, we need the brace on there. I'm going to fasten the brace so that the valve is north. That means that any dirt and grime and water or anything like that that attacks the spare will probably attack it from an underdog position. As easy as pie, and by pie I mean attaching 2 bolts. we're ready to lift. Let's hope it goes well. That's not how it goes. Silly. Goes that way. I'm gonna should have read the manual. Tickety-boo. And as you know, this is now the dangerous part where I need to put the bolts in. It's currently only hanging by the wire, and that's not technically very secure, so let's put some bolts in carefully. What you just saw me do there is something that has happened before, and I'm aware of it, and it's not going to be a problem. What happens is that the end of this one gets wedged into the socket for the winch, and in this case I've just painted this. It worked fine the last time I used it. The first time I used it, it got stuck again, and then I opened it up a little bit more, sanded this part down, but now, as you might or might not see in there, the paint is a little bit damaged, and therefore it got stuck in there. If it gets stuck again, the solution is simply to get in there with this type of tool, some pliers or something, or a 30mm spanner, and just hold the shaft of the winch itself. I can just crawl under there. It's an inconvenience, not a problem. So, thank you. Looks like the spare wheel carrier is now done. Well, we're probably going to slap some paint on all the exposed nuts and stuff like that. But apart from that, mechanically it's all tickety-boo. If I were to be really picky, then maybe another wire would be more suitable, but another day perhaps. As I said in the beginning of the video, there are many options for mounting your spare wheel. This is the one we chose, and yes, it does intrude into the living space a little bit, but we think it's a good enough compromise for what we need and want to do.
It seems I always get some stick for mentioning weights, especially when we're talking about a 7,500 kilo truck. However, I believe that all the savings will eventually have a benefit. A lighter vehicle means less wear, better handling, and maybe even a little bit less fuel consumption. Or we can carry stuff that we actually like. For example, food is more useful than a towing hook we can't use. Let's start with the easy bit and the big weight saving, the crossmember. The old one is over 41 kilos and the new one is just under 14 kilos. That's a saving of over 27 kilos. Which in turn would allow us to carry over 50 bottles of beer or give us 140 kilometers extra range if we use the weight saving for diesel. Then the spare wheel carrier. The original one is 16.5 kilos and the new one is 9 kilos. Then we need to add the complexities like the winch, brackets and such. We end up with a total weight of just under 14 kilos for the whole system. Keep in mind that the wheel bracket was part of the original system. The saving is just under 6 kilos or 11 bottles of cold snacks or about 7 litres of dino juice. When we tally it all up, we've saved roughly 33 kilos, and in familiar values that's 62 bottles of wobble pop, 20 bottles of plonk or 40 litres of the stinky stuff, which would give us an added 200 kilometers range if we use the weight saving to fill up with diesel. Keep in mind that these values aren't super accurate and there's a few things that aren't included, such as the winch stick, etc. Overall, I'm pleased that we've shaved off some weight and hopefully it'll make a difference down the line.
I think this is where we'll end this episode. I hope you learned something or at least had a laugh. So without further mumbling, I hope to see you in the next one, and thanks very much for watching. I'm quite tired.